Hello everyone. In the previous video, we discussed the theory of the single index model. In this one, we are going to use Excel to implement it. For doing that, I downloaded the monthly price data for Google and the S&P 500 index from Yahoo Finance. This was done for a period of 5 years from December 2006 to December 2011. I then computed the raw returns for both series, which are here in these two columns. Google's raw returns, RR stands for raw returns, and S&P 500 index's raw returns. When we say raw returns, we mean that the risk-free rate has not yet been subtracted from them. We are assuming the risk-free rate to be 0.0044 over this 5-year period, and this column has the risk-free rate. In order to implement the single index model, we need excess returns, which we are going to have in these two columns here. But if I have to do that cell by cell, this is going to take an awfully long period of time. Instead, what we are going to do is to select some data ranges and quickly find out the excess returns for Google and S&P 500 index. So I'm going to select my data range for raw returns first. Once this selection is done, I'm going to name my data range. This here is the name box. But before I can enter a name into the name box, I need to make sure that there are no other names or there are no other data ranges that have been given some names already, which might interfere with our new names. The way we can check this is by going to the Formulas tab here and then clicking on the Name Manager. Once you see this box is empty, it tells you that there are no data ranges that have been given a name in this worksheet. So this is fine. I can click it close and I can now give my selection a name. This is the name box. So I'm going to write here raw underscore ret. So this data range is my raw returns. I can do the same thing with this data series here. This is my risk-free rate. So I can give this series a name RF. Once I have done that, I can very easily and quickly find out the excess returns for Google and the S&P 500 index. This is the region in which I want my excess returns to go. So I'm going to select this region. Keeping the selection active, I'm going to type in this cell RAW underscore RET minus RF. And so that the entire selection of my cells gets filled with the excess returns, I'm going to press Ctrl, Shift and Enter at the same time. So I have very quickly found out the excess returns for the entire length of time for Google and for the S&P 500 index. Let us now look at some of the statistics for these two return series. We are interested in the standard deviation, so let us calculate that here. We are using the stdev function to calculate the standard deviation of excess returns for Google. So this is our standard deviation for excess returns for Google, 0.1017, and this is a monthly standard deviation because we are using monthly data. We can drag this formula across to get the monthly standard deviation for the index's excess returns. We can also have a look at the annualized standard deviation. In order to find out the annualized standard deviation, we can multiply the monthly standard deviation by the square root, SQRT, of 12, 12 being the number of months in a year. So this is our annualized estimate of standard deviation for Google's excess returns, and we can drag the formula across again to get the annualized standard deviation for the index's excess returns as well. We can also find the variance of returns. So in this cell, we are finding the monthly variance of Google's returns by using the VAR function. So here we have the monthly variance for Google's excess returns, and we can drag the formula across to get an estimate of the estimate of the monthly variance. Rather, I was about to say annualized variance. So this is the monthly variance for the excess returns of the index. Now we can annualize the variance. In this cell for Google, what we do is we multiply the variance by 12, and we can drag this across to do the same thing for the index. Now let us proceed to implement the single index model. We know from before, from a previous video, that the single index model is arrived at when we regress the excess returns on the market on the securities excess returns. So we are going to have to run a regression. For doing that, we need to go to the Data tab and select Data Analysis. The Data Analysis add-in should be installed on your machine. If it is not, you should install it first to proceed further. So once this item is active here, we could select this, and then from this dialog box we could select regression, and Excel is going to ask us to provide our Y range of series and the X range of series. What is supposed to be our Y range of series? What is the dependent variable? The dependent variable is Google's excess returns, and it has already been entered here in this field already. This is because I ran this regression a little while ago. You will see that Google's excess returns are in column E, and the first value is in cell E2, and if you scroll down, you're going to find that this series goes on till cell E61. So that is what has been entered here in this field. The X range, or our X series, is the market's excess return, and the market's excess returns are in column F. The first value is in cell F2, and it is going to go on down till F61. So that is what has been entered in this field here. I want my output to be returned in the same worksheet, so I have to specify an output range, which is cell H1, this cell here. This is where I want my output. I also want Excel to return the residual output to me, and that is why this box here has been checked. So when you are running the regression, make sure that you have checked the box for residual output. Once we are satisfied, we can click OK. And now here we have our regression results. Let us take some time to look at these results and interpret their meaning. We are going to focus first of all on this panel here, regression statistics. The first item that we see here is the multiple R, which is 0.6049. This is telling us that Google tracks the S&P 500 index fairly closely. The next item here is R squared, which is our coefficient of determination. This is equal to 0.3659 or 0.366, telling us that about 37% of the variation in Google's excess returns is explained by the S&P 500 index. If we move down, we see this value for adjusted R square, and you will notice that this is a little bit lower than the value for R square on top here. Why is this lower? This is because we are working with estimated values for intercept and slope in our regression. We would have liked to work with the true values, but alas, they are unknown. So we have to work with estimates. And adjusted R square is simply adjusting for the estimation error in the coefficient of determination. That is why it is a little bit lower. The next item that we see is the standard error of regression. In this case, it is 0.08167 or roughly 0.0817. In terms of the single index model, This is the standard deviation of the residual return. Let us go down to the residual series and check this. This is where we have our residual output. In this column, we have our predicted Y values, which means that these are the values for predicted excess return for Google. And in this column here, we have the residual term or the error term from the regression. Let us work with our residuals and see a few statistics about it. We want to see the standard deviation of the residual. So we can calculate that in this cell, STDEV, and we are going to provide the series. Let us see what we get. We get 0.0810, which is not very different from what we see at the top here, 0.0816. So this is roughly the same. While we are working with the residual series, let us also have some more statistics. Let's also calculate the variance of this series. The variance of the residuals, you will remember from the single index model, is going to be the unsystematic part of our risk. So we can calculate it here one time. So we can say VAR for variance, and we can provide the series again. Let us see what we get. This is 0.0066. This is our unsystematic risk for Google basically. We are also going to calculate the unsystematic risk by using our ANOVA results in a little while. We also saw in the previous video that the mean of the error term or the mean of the residual term was assumed to be 0. Let us check this out. We can find the average of the residuals. Let's hope it is equal to 0. Let us see what we get. We see that in fact the mean of the error term is 0. So on an average, there is no residual return. Now let us scroll up and see what else we can find out. Let us look at this section of our regression results, which give us the ANOVA results. From here we can find out the variance of Google's return. We have already found out the variance, if you will recall, down here. It is equal to 0.0030. Well, this is for the market and this is for the security for Google. So the variance of Google's excess returns is 0.0103, and we are trying to get the same result from our ANOVA numbers. How do we do that? Let us do it here in this cell. If we want to find out the variance of Google's excess returns from our ANOVA result, what we need to do is to divide the total sum of squares, which is this number here, 0.6102, by the degrees of freedom, which is 59 here. So we select this. Let us divide, and hopefully we should get the same result. So this is the variance for Google's excess returns, 0.0103, the same as we saw a little while ago. We can also find the systematic risk for Google. Let us do it by using the index model first. According to the index model, the systematic risk is equal to beta squared times the variance of the market. So let us do that here. What is our beta? This number here, the coefficient for the x variable, is our beta. So we are going to select this and square it up. After that, what we need to do is to multiply this by the variance of the market. We had calculated the variance of the market a little while ago. Let's go there. This was the variance of the market, 0.0030. So we select this cell and hit enter. This is the systematic risk for Google. We can also find the systematic risk by using our ANOVA results. Let us do that in this cell. What we need to do is to divide the sum of squares for the regression, which is this item here, by the degrees of freedom, which is 59. When we hit enter, we see the same result returned again. So this is the systematic risk for Google. We can also find the unsystematic risk. Well, what is the unsystematic risk? The unsystematic risk is the variance of the residual. We already found that out here. Let me scroll down and show that to you. This was the variance of the residual, 0.0066. But we can find the same thing from our ANOVA results as well. Let us try to do that in this cell here, the unsystematic part of the risk. This is going to be equal to the sum of squares of the residuals, because we know that the unsystematic risk arises from the residuals. This is the sum of squares here for the residual, and we can divide this by the degrees of freedom, 59. So this is the unsystematic part of Google's risk, which if I scroll down, you will see it's going to be the same as this, 0.0066. What else we can do with our regression results? We can check for R square. R square, or the coefficient of determination, can also be determined from our ANOVA results. In order to find out R square, what we need to do is to divide the sum of squares of the regression, which is this, by the total sum of squares, which is this. Hit enter, and we see the same value as this. So even if you didn't have this value before, if you had only the ANOVA results provided to you, you could still find out the coefficient of determination by dividing the sum of squares of the regression by the total sum of squares. You could also do this through an alternative way. You could say 1 minus the sum of squares of the residuals, which is this, and you can divide this by the total sum of squares, which is this. Close bracket and hit enter. We see again the same value, which is the coefficient of determination. Alright, so let us now move on to our actual regression results, which are going to tell us about the single index model. This is where we have our results. This item here is the intercept, which is the alpha from the single index model. This is the standard error. This is the t-statistic, and this one is the p-value, or the probability value for obtaining the alpha that we have obtained. We can immediately see by looking at the p-value that alpha is not significant, at least not at the 5% level of significance. In order to understand this, you need to know that we are working here with a null hypothesis that alpha is equal to 0. What we see from our results is that there is a 27% chance of obtaining the alpha that we have obtained, this one here, and this 27% is pretty substantial. This tells us that probably our null hypothesis is true. Let us go over it one more time. If our null hypothesis is true, we have a 27% probability of getting this value for alpha. We would have rejected our null hypothesis if this probability was 5% or less, which we call the 5% level of significance. Since this is not so, we cannot reject our null hypothesis that alpha is equal to 0. Therefore then, this value of alpha is not statistically significant, and we can say that in this case alpha is basically 0. What about the beta, or the slope coefficient? This is where our beta is, the coefficient on the x variable. What we see that there is hardly any probability for obtaining such a beta. This is almost 0. If I change this by formatting the cells to display 0 decimal places, you will see that this probability is 0. What does this mean? This means that under the assumption of our null hypothesis, which is again that beta is equal to 0, we can reject the null. This means that this beta estimate is statistically very significant. We are rejecting the null hypothesis that beta is equal to 0. Here we have the lower and upper 95% values for our coefficients. What does this tell us? This cell here tells us, or this range of cells tells us, that the actual alpha may be somewhere between minus 0.009 to plus 0.03. So there is some uncertainty about the intercept or the alpha. We said before that the adjusted R square is lesser than the R square because we are working with estimates, and estimates always have some degree of uncertainty about them. So this is telling us the range between which the actual alpha could lie. And similarly for beta, it could range from positive 0.73 to positive 1.51, where this is our estimate. So there is some uncertainty about our estimates. That is why the adjusted R square was a little lesser than the R square. So what we can say in totality now? We can say that Google's excess return is obtained mostly from its sensitivity to a change in the excess market returns. And though we love to have alpha, there is no significant alpha on offer here, which means that there was no non-market premium for Google for this time range. We can also plot our results and see them graphically. We can plot a characteristic line actually. Let us do that here in this space. For plotting our results, we are going to go to this Insert tab here and select the scatter plot, and I'm going to go with this one. So I have a graphing space which I can move here so that it doesn't overlap with our data results. Inside this space, I'm going to right click and then select data. We see this dialog box here. We are going to add our series that we want to have on the graph. So I'm clicking add, and Excel is asking us to provide a series name. So let us first of all plot the actual returns or actual excess returns for Google. For doing that, we need an X series and a Y series. What is going to be our X series? The X series is going to be our market's excess return. So we are going to select that here. Looks like I selected these parameters also. So I will do that one more time. The series actually ends here. So I'm going to scroll up and provide the values. What is going to be our Y series? The Y series is going to be the actual excess returns on Google, which are here in this column, column E. So let us select column E and be careful not to select the statistical parameters that we calculated before. So we have made our selection. We can click OK and see how it looks like. Let us see how the graph is looking. These are our actual returns in a scatter plot here. We can superimpose our predicted returns. This column here gives us the predicted value of Y, where Y is our excess return for Google. So let us plot these returns as well. So we go into the graphing space, select data, and we are going to add another series, and we are going to call this the predicted excess returns. The X series is going to be again our excess returns on the market, which are here. Actually, let me begin from this point onwards upwards so that I don't select by mistake the statistical parameters that we calculated. So this is our X series, S&P 500's excess returns, and now we want the predicted excess returns for Google, which are in this series here. So we can select this. Click OK, and let us see how it looks like. Well, this is our predicted returns, pretty much a linear relationship as expected with a regression line. If you wish, you could plot a trend line, and that would be called the characteristic line, where on the x-axis we have the market's excess returns, and on the y-axis we have the securities excess returns. So you could click on any of the points here on this red series. We are right clicking, let's say, on this point, and we can say add trend line. Let us format our trend line a little bit. I want a solid line so that it can be seen distinctly. It's asking us which color we want. Well, green is fine, good enough. The size of the line is pretty thin, so we can make it a little thicker. Line style, we can increase the width of this line. So let's say it's equal to 3 points. So it's a little wider and we can see it properly. So we have our characteristic line here. What do we see from this graph? What we see is that this line here and the returns that plot on it are our predicted values from the regression model or the single index model, and the blue dots that we see are the actual excess returns. The distance between this green line and the blue dots is the residual, basically. So these residuals are the distances between the blue dots and the green line. This is all I wanted to tell you in this video. See you later.